finding special products of polynomials. Again, we're multiplying polynomials together here, and whether it's monomial methods, there's table method or FOIL method. But as long as we make sure we multiply all the terms in the first one by all the terms in the second, first part of this section, we talked about a certain pattern that always happens, and again, if you can use that pattern by doing this problem right here. So the directions might say, find the product. So that means we're multiplying these two binomials together. Again, they're binomials because they have two terms. And so I'm going to find the product of these two binomials by using one of my methods, either table method or FOIL method. Let's use table. X minus 5 up here, and then x plus 5 here and along the left side. And I can multiply these two binomials together. Let's see what we get. X times x gives me x squared in the top left corner. X times negative 5 would give me minus 5. 5 times x gives me 5x. And 5 times negative 5 would give me negative 25. Now I'm just going to collect the like terms and write my answer. Well, I've got x squared as my highest power number. And then I've got here, notice what happens in this particular problem. 5x and negative. There are no x's, so I don't even have to write that. It's like 0. Those two, since I have the positive and the negative of each one, they just cancel each other out. 5 minus 5 gives me 0, so those kind of go away. And then last I have negative 25. So in this problem, I actually end up with a binomial as my answer. Many times multiply a couple binomials together, we usually got a trinomial. Well, in this case, though, I just get two terms. X squared minus 25. I get a binomial for my answer. I'm showing you this problem because in the first part of this section, we talked about a particular pattern that always happens when I'm multiplying binomials squared together. Pattern with these types of problems as well. Anytime I have the binomial that looks for two binomials that look pretty similar, but one is plus or addition and one subtraction, otherwise they have the same terms, there's always a pattern that happens with these as well. So if you have like these, there's a similar pattern that you can always just jump to the answer because you know this is always going to happen in your table method or your FOIL method. Things are going to cancel and you can go right to the end result. On the first part of this section, here's what I'd like you to write down if you're taking notes along with me. This one's called the sum and difference pattern. And kind of sounds like the binomials you see are just like what it says here. There's a sum and there's a difference. There's a binomial that's subtracting and there's a binomial that's adding. But if those two binomials have the same terms, they both have a here and they both have b here, and one's adding and one's subtracting, what's always going to happen is your result's just going to be a squared, so that number times itself, and b minus b. And we can usually come up with, well, because no matter what, when you multiply b and b here, one's negative and one's positive. So a negative times a positive is always going to give me a negative. So for this sum and difference pattern, you always get a subtraction sign there. Whenever I'm multiplying the same by subtraction, I always get a squared minus b squared. That's always the answer. Again, looking at an example here with actual numbers and variables in it. X minus 4 and x plus 4. The result's going to be x minus 16. And down below here, I'll just show why does we understand. I'll do this one with FOIL method. So if I multiply the first terms together, x times x gives me x squared. The outside terms, 4 times x, would give me 4x. Inside terms will give me negative 4x and negative minus 16. And again, so why does this always work in this sum and difference pattern? Well, as you can see, what's always going to happen is if I have these same terms multiplied together, but one's positive and one's negative, okay, when I do the outside, I'm always going to get the positive of that term then, and then when I do the insides, I'm going to get the negative of that term. So these two are always going to cancel each other out then, and they'll be out of my problem, and my final result will just be x squared minus 1. Difference pattern, that middle term always cancels itself out. So this is why we can always just actually jump to this answer and go right to that for our final result. So just looking at a few examples of this together, and again, I think this won't have to necessarily memorize it. It'll come to us regardless, even if you don't realize it right away what kind of problem it is. It says find the product, t plus 5 times t minus 5. So again, if nothing else, if you wanted to in this problem, you could still do FOIL method or Tail method, and you could go to this, and I'll say t and 5 and t and negative 5, and when I start multiplying things together, I get t squared, I'll get 5t, I'll get negative 5t, and I'll get negative 25. And then when I start collecting my like terms, I'll get t squared and 5. If you want, you can wrong with that. But if you can kind of see the pattern here, and you notice it right at the beginning of the problem, ooh, this is t plus 5 times t minus 5. What's always going to happen in these problems is you could do the first one squared minus the second number squared. So doing that 10 and x minus 10, what will I end up getting here? I could do a table, or I could do FOIL method, but we'll find out that I'll end up just getting x times x, which is x squared, and then 10 times negative 10 squared. And that middle term would end up canceling, so I just get x squared minus 100. And then this last one here, so 3k plus 4 and 3k minus 4. 3k 4 here negative. The outside and the inside terms. The outside terms would give me negative 12k. The inside terms would give me positive 12k. So you have that pattern. Those just cancel out. Now in this section, 9.3. So far I've touched it. There's kind of two different shortcuts or patterns that happen that would allow us to just jump right to the end answer. It's a very nice thing. It's nice to be able to cut out some steps sometimes and shorten our work. So that's a great thing. Don't have to memorize these rules necessarily. Like you don't have to know them right offhand to be successful or to be able to multiply polynomials together. These are just that. They're just shortcuts. Just a way to get to the shortcuts. It's not the worst thing in the world. What's the worst thing that would happen on a problem that has a certain pattern to it? What would happen? Well, as long as, and this is why I said this in the first lesson, as long as you do remember, though, that x minus 3 squared means that will still be fine, because we can still get to the correct answer. I could just, and I could use one of my methods. Let's say I use FOIL, x squared minus 3x minus another 3x plus 9, and then and you would still get the correct answer. Or what the shortcut was? Well, I didn't remember it. That's okay. I still got to the correct answer. I just kind of I had to go the long way again. I had to do all the steps. And like go home and you have to study these patterns, you know. Right. They're nice patterns. They're ones that you should know. But realize if you couldn't jump right from here to the end, you could still get the right answer. just by doing what we normally do. Okay, by writing out the method and then finding the answer. Same thing with the plus. Okay, so again, these are just shortcuts to the finish, but if you don't you could still just start doing the problem like you always do. If you saw x plus 2 and x minus 2 in this pattern, the sum and difference pattern, you didn't think about that right away or realize it, you're just kind of going through your work as you usually do, that's fine. You could still go negative 2x and negative 4. And then when you start collecting, these two cancel, and then minus 4. And so even without knowing the shortcut, without going this direction, you still got the right answer. You just had to make your table and then your answer. But it doesn't this section or worry about trying to memorize just shortcuts. They're nice, and if you know them, they can get you to the answer quicker, which we always like. But if you don't know them or don't memorize them offhand, that's okay. You can still get to the right answer. Put this together with FOIL or table method.